Okay, good morning. May 25. This is the May 25 meeting of the Cosmology discussion group. So welcome to everybody. And I see Jerry is here, Bob,
Yep.
Ian, Vladimir. We got the usual suspects. So Jerry has offered to give us a talk today about the invariance of light. And we have no other discussion here. I'll let Jerry get going. Does anybody have any comments before we start? All right, Jerry, you want to share your screen or do you just want to start talking?
Well, I guess I'll just read. I didn't prepare slides. I always have trouble with them, or I forget to present them as I read because I usually don't print everything on the slides. I ought to, but I always have trouble knowing how large to make the fonts and everything. So, anyway, I'm
Well,
going
before
to.
you start, let me ask you, did you take a look at the emails that have been flying back and forth?
Oh yeah, yeah, yeah. I responded slightly here and there. I was going to respond more. I haven't yet though.
All right. I have the feeling this may be a contentious topic. So, all right. So
Yeah.
go ahead.
Okay. Here we go. Uh, why would an electromagnetic wave always measure at 186,282 miles per second, regardless of the motions of the observer and light source? This question has puzzled me for many years. Why wouldn't the relative motions of the observer and light source factor into the complete velocity of the light wave? For example, when you stand on a truck that travels down the road at, say, 55 miles an hour, and you throw an object at 25 miles per hour in the direction of its motion, the velocity of the object adds to the velocity of the truck for an equal total of 80 miles per hour. Why doesn't light act the same way? Why wouldn't the relative motions of the observer and source affect the velocity of light? The Lorentz transformations and special relativity were designed to account for this unusual effect. There was the popular scenario that Lorentz and Einstein considered, where an observer travels with a light wave that the source emanates at a distance. That as it travels away, the faster it goes, there seems a discrepancy for which they thought they needed to account in order to preserve the invariance of C through different frames of reference. As the observer travels however fast relative to the light source, it continues to measure the standard value of C. So Lorentz theorized that the units of measurement, or even the objects themselves, would shorten in the direction of their motion. This seemed to provide a way that things could stay consistent with the conditions created by the invariance of C. He might have thought that Newton's equation, distance equals velocity times time, didn't apply in this scenario, since there was a lot of extra distance to account that was unaccounted for, such as when the observer travels so fast relative to a light wave and C stays invariant, something would have to give. So if he transformed the units of distance or the lengths of the objects, it would seem to equalize the elements within the equation. He also predicted mass increase and even time dilation before Einstein agreed with them and set forth his theory of special relativity. They thought these relativistic effects would seem to equalize the elements in Newton's equation. These systems were meant to account for the velocity of light in a linear way where the scales of time and space, or distance, transformed to maintain perfect equilibrium. They eventually adapted and expanded the original scenario of the observer who travels relative to a light wave. The purpose of the scenario was to account for the invariance of C. So how to account for it when there isn't electromagnetism present? Of course, a light source is an object, though most objects aren't light sources. So the theory eventually started to apply to all objects, where the length of objects would contract and other relativistic effects would occur as they travel fast relative to each other. As they travel, and the faster they travel relative to each other, these effects would increase exponentially. I've read that if an object could reach the velocity of light, its length would shorten to zero and its mass would grow to infinite size, and that time would even stop. Since these effects seem impossible, is part of the reason they might why they say that nothing may reach or exceed the velocity of light. Here's another question. If the length of objects shorten as they travel with a light wave, why wouldn't the objects expand in length when they travel in the opposite direction or towards the source of light? Why isn't this more of a symmetrical process? All of these complex ideas were developed to account for the invariance of C. I have a question though. What if for some unknown reason light just happens to propagate and register that way whenever measured? If the velocity of light is indeed invariant, why isn't it simply a phenomenon that is misunderstood and unaccounted for? Of course, mathematicians have developed complex systems that create these relativistic effects. However, what if the invariance of C is just an anomaly we don't yet understand? What if there is some other underlying principle of which we're currently unaware? So is C invariant? There is much debate over whether C is actually invariant. There are experiments that have called this into question, such as the Sagnac effect, the Michelson and Gale experiment, and the Wang experiments with fiber optics. With each of these, one of the two light waves has to travel more of a distance than the other, which is maybe why the interference fringe pattern shows up. I think this is the mainstream view, though I don't know for sure if it is correct. If C isn't invariant, how does light propagate instead? I've often considered C is possibly variable, whether it is where velocities add or maybe if it works in some other way. If this is so, it calls the Lorentz transformations and special relativity into question, which opens the door to other interpretations of reality. However, even if C is invariant, does it automatically follow that these theories were on the right track? What if the Lorentz transformations and special relativity began as speculative hypotheses to explain the invariance of C, and if they gained attention and wide acceptance since there weren't any other clear alternatives? Was it necessary to overhaul our understanding of time, space, and mass just to explain why light is said to travel at the same velocity? For years, I simply didn't believe in the invariance of C. I had repeatedly asked people in forums and even Google what experimental verification there is for the theory. They seem to always refer to the Michelson and Morley experiment. When Michelson and Morley's experiment failed to detect the ether, it is often said that these results prove the invariance of C. However, the light source and sensors within the interferometer were in the same reference frame, fixed and stationary relative to each other. The only way to determine if C is invariant is if one of them were in motion. It is also commonly thought that Michelson and Morley disproved the ether. However, it might only provide verification that light doesn't travel at a fixed velocity relative to the ether. However, there's also the two-way velocity of light to consider. I'm sure most of you have heard of this quandary, possibly through the Veritasium video. Of course, the Earth has quite a variety of motions, the direct motions such as its spin and orbit around the sun, and also the indirect motions caused by the sun's motion through the galaxy's further motion to the universe at large. If it were possible to get a one-way measurement and light only travels relative to the ether, it would seem that you could never get the same reading twice, since if you were to check it again a few seconds later, the Earth would have already have a different position and velocity in the universe. If at any given point in time the velocity of light is detected, one direction might measure it as, say, 75% C, while the other might register 25%. When the velocity is measured with the two-way approach, they would seem to equal the complete 186,282 miles per second. Any other configuration or direction and velocity with reflectors would arrive at the same value. Of course, Einstein created the synchronization convention, which states that light travels the same velocity one way as it does the other. However, this is only an assumption since measuring the one-way velocity of light is currently impossible. I I've had this idea for an experiment for years. If it's possible to measure the velocity of light precisely within a lab, is it possible that they could set up an experiment where there is a super fast vehicle that propagates light or maybe some other electromagnetic wave to a receiver at a distance in order to determine if C is actually invariant? Is it possible that the velocity of the vehicle would add to the velocity of the electromagnetic wave? This might seem a good idea for an experiment if it were possible to set up. To set up such conditions would require the synchronization of clocks to measure the light wave and the vehicle that emanates the light. It would require motions, even accelerations, to get the vehicle going fast enough to determine if C is or isn't invariant. Of course, accelerations interfere with the proper workings of atomic clocks, and even constant velocity is said to cause time dilation. So this particular experiment seems currently impossible to create. A friend has recently told me of an experiment where physicists accelerated particles that glow and that a sensor picked up the light of their glow at the accepted value of C, where the velocity of the light of their glow didn't add to the velocity of the particles themselves. This initially made me much more receptive to the invariance of C, though I continue to maintain a high level of skepticism. I remember I thought, why hadn't I heard of this experiment after searching and asking the question for years? For quite a while, it seemed conclusive. I kept searching for the details of the experiment, though ChatGPT and Google couldn't find the experiment at all. I asked ChatGPT if it wasn't a real experiment, what if we could actually set up such an experiment? One thing that ChatGPT pointed out that I hadn't considered was that to measure the light of the particles glow, you would have to have a starting point, a definite time when the glow started, which would seem impossible to determine. So as it turns out, there doesn't seem any adequate experimental verification for the invariance of C. It seems that we're currently limited by our technology to discover the truth. That's all. I can't hear you, Harry. Harry, I can't hear you.
I muted so that
Oh, okay.
you wouldn't hear me when I cough. And now I'm going to cough.
Okay.
All right. Okay, that was an abrupt ending there. You didn't give us any warning.
Well,
Uh,
yeah, I mean, I
do
sort
you
of
have some kind of a conclusion or summary? A summary
well,
conclusion or
essentially, how to know the invariance of C isn't just a mysterious and misunderstood anomaly that we don't know how to currently account for.
so
And that,
you don't see it as a scientifically established fact, as I suspect some people who are believers would say.
oh, well, I mean, I just maintain a high degree of skepticism of,
So you're maintaining a high degree of skepticism. Okay. So
So,
you're
so
not
you haven't
convinced.
expressed any particular position. You're just saying, well, you're not sure. You're agnostic about the affair. Is that correct?
well, I would want to question the validity of the Lorentz transformations and special relativity of needing to account for the distances of objects or the lengths transforming to account for the invariance of C. What if the invariance of C? What if it just registers that way? And what if there's an underlying principle we're unaware of that causes that we develop these complex systems of mathematical ideas to account for it when maybe they weren't necessary.
I also have expressed, as you know, the view that the term invariance of C, which is widely used, is rather all embracing and actually imprecise, and one should really separate the phrase into two aspects, namely the invariance of C with source motion versus the invariance of C uh, with observer motion. Now, it seems that the Einstein originally just took at a second postulate the invariance of C with regard to source motion, which is actually correct. It's true for all wave motion. But he then introduced the reciprocity of the Lorentz transformations, which means that um, the invariance of C is also true for observer motion, which I would say, and I have said this, is manifestly untrue. We have theoretical and quite an amount of experimental data that shows that to be untrue.
Well, Ian, you mentioned on different occasions that that when the observer is in motion, that C isn't invariant. When it's stationary, well, I forget which is which, but one of the ways, I think it's what that was correct, but one of the ways that C isn't invariant, and I've looked for that experiment online, I can't find it. Would you possibly know the name of it?
Well, I'm not sure which one you're talking about, Jerry. Is it the radar ranging experiment, for example?
I don't know.
Radar ranging of Venus.
Well, I think, Ian, you gave us an example when you were talking about Romer's measurements. I think you gave us an example where the velocity wasn't constant relative to motion of the observers on the Earth. Isn't that correct?
Actually, I forgot to include that. That is a significant discovery that I completely forgot about that. Romer's observations, which seem to which I mean, like with the delay of the viewing of the eclipses, that seemed to disprove the invariance of C. However, though, I mean, it doesn't mean that velocities add, like precisely. But if they don't, how does it work?
Yeah. So that's right. And I think it was Jim during that discussion who pointed out, well, maybe the accuracy of those experiments in the late 1670s or the early 1670s wasn't sufficient and should do a statistical analysis. But yes, they seem to show that there was a variation of the speed of light depending upon whether the Earth is moving towards or away from Jupiter. But the more modern experiments, have been done, basically analyzing a similar effect with regard to Jupiter. Sorry, I beg your pardon, mixing with Venus. And the man is, I've just forgotten his name for the second now. He did the analysis, but I talked about him at the time. But I would maintain that actually, if you do a simple, classical physics analysis of the Sagnac experiment or the Michelson-Gale experiment, you're forced to concede that you mentioned this yourself actually a moment ago. You're forced to concede that the speed of light is not invariant with respect to the observer motion.
Well,
and actually, the equations come out most easily if you accept that it is invariant with respect to the motion of the source.
Yeah.
Can I ask for a clarification there? In the Romer experiments that you described, Ian, if the vacuum speed of light was indeed invariant, a position that I'm not endorsing, by the way, but if it were, could the differences be accounted for by the motion of the Earth? In other words, the motion of the observer? Do you understand the clarification I'm seeking on that? In other words, the differences that you reported, the Earth going away from Jupiter or toward Jupiter, could that account for the data, its velocity, the Earth's velocity, with the speed of light being constant? Am I being clear on what I'm asking?
I think so. I think, correct me if I'm not taking it correctly, Jim, but as far as I can see, that's basically the way the mainstream explain away, I would say, the Sagnac effect, because they would say when the observer, in other words, the detector, is moving with the spin of the disk, it has further to go before it reaches back to the origin. But if it's moving against it, it has less of a distance. So that's the simple explanation. But that is precisely, I would say, what non-constancy of speed means. So in other words, if you have two motor cars driving down a road, and one is driving at 30 miles an hour and the other is driving at 50 miles an hour. Well, why is the relative speed 80 miles an hour? Because the distance is becoming closer. The distance between them is becoming closer. And similarly, if they're receding from each other, it's the converse. But if you're in one of those vehicles, the relative speed is actually the sum of the two.
Okay, but is it possible in your example with the two cars that the one representing light speed, say going 50 miles an hour, is in fact constant, and that the data can be accounted for by the motion of the other car, which would be the Earth in the Romer data analysis? Again, I'm not.
I mean, to me, I think these are two equivalent ways of looking at it. I mean, you're looking at it one way from the point of view of the distance changing, and that's true. If you were in outer space looking down at this at the Earth as a moving car, if you like, and the ray of light is the other moving car, yes, what you say is correct. That's the correct explanation. But if you're actually on the Earth, well, the speed of the light that's actually reaching you, or
it would appear to be different, but it may not be. Is that what you're saying, Ian?
Well, those are your words, Jim. But it not any more or not any less than the car which is approaching you. You're doing 50, and there's a car approaching you at 30. Now, if I say the relative speed is 80, and you say, well, it isn't really, it only appears to be. Yes, you could say that in the same sense.
And so really you need an absolute frame. That just occurred to me at this moment. I was actually just seeking clarification, but it seems to me that you laid out exactly why an absolute frame is necessary.
Yeah, well, okay. That's maybe jumping the gun a bit. I mean, I'm not going to argue with you, Jim, because we might have some similar views, but you might say that is why an absolute frame is convenient. I would certainly say that that's what's coming out of our discussion now. But as regards it being necessary, we might have to go a bit further to establish that.
Okay, I'll be quiet. This is very interesting. I want to hear other people's ideas as well.
One point I wanted to make, Jerry, is there actually were quite a few experiments done with moving sources, including like rotating mirrors. I know Michelson did one, and there were several during the 1960s with radioactive neutral pions, and they would measure the rate of gamma rays being emitted. And essentially all of those had negative results. There was a controversial one by Wallace Cantor with a rotating mirror where he said that he did observe a phase shift, but people weren't able to replicate it. If you like, I could send you the literature I have there. It's fairly extensive, actually. I don't know if it's all convincing because there are some counter moves you can make, including that if the experiment's not done in a vacuum, that you get a new source and things like that. But as far as I know, there's no really convincing evidence at the moment that the speed of light is relative to the source. Personally, I'm sympathetic with a theory like this, but it really needs experimental confirmation of some sort, which, as far as I can see, just isn't there right now.
Well, I personally didn't believe in the invariance of C for so many years, and okay, with the glowing light of the particles, that made me sort of more convinced because Michelson-Morley, I mean, like with the Michelson-Morley experiment, the light source and sensor are within the same reference frame. So if one was in motion, that might make a difference, but it might disprove the ether, or maybe it doesn't. Or it might just prove that that the light travels relative to only the ether, but then there's the two-way velocity of light. Anyway, I'm currently unsure if C is invariant. I'm just open to the possibilities. I think the Michelson-Gale and the Sadek effect and the Wang experiments that light has to travel at more of a distance one of those ways, which could result in the interference fringe pattern. I don't know if C is invariant though, but I don't know if that's proof that it isn't.
Guess the question is who has the burden of proof, maybe.
Well, we're always saying the speed of light in a vacuum. We already know that in what we consider to be not a vacuum, for example, in the presence of ions or atoms, that we have refraction and phenomena which change the speed of light. My own work points out that in fact that at very low energy densities, a volume is opaque to light. In other words, that the speed of light is zero, mainly because all the incoming energy from a light signal is absorbed first before there's enough density of energy in the volume for light to transmit.
Well,
So this whole idea
I don't know
of
if the
vacuum
absorption of
speed
light
of
would
light
affect
is
its
sort of
velocity,
a
though.
tenuous concept.
Yeah. Well, I mean, as far as the vacuum, the velocity of light through a vacuum goes, I mean, I would guess that just simply through the air on Earth, that the value of velocity of light is probably very close to that. I would guess. Through water, it's like 3/4 or something. But I mean, I couldn't see that the deflections and such through various particles in the air would affect the velocity that much just in the air. I mean, maybe it does to some degree. I'm sure it does to some degree.
By the way, Jerry, I've just looked up the reference I couldn't remember
Oh,
that you
cool.
asked earlier. It's Brian Wallace or B.G. Wallace. He analyzed the MIT Lincoln data from the early 1960s. If you Googled B.G. or Brian Wallace Venus ranging analysis, you'll get some papers. Wallace, Wallace.
All right, I'll have to look that up. Thank you.
Well,
Okay, I'm gonna throw in philosophy here. What do you think, Jerry? What do you think invariance of light velocity means? Is there do you
Well, the velocity of light is always measured the same, regardless of the motions of the source and the
all
observer.
right? So you said
Essentially.
that so your definition relies on the concept of measurement, right?
Well, sure, yeah.
Okay. So so the question sort of goes down to what kind of measurement procedure we're using. Does that seem to be what you're saying?
Well, I mean, just anything that clocks the velocity of light, like any sort of device that measures the velocity of light is the instrumentation that is necessary in order to achieve that. I wouldn't say that Lorentz transformations, like as far as measurement goes, I don't know if I don't know how accurate that is personally.
Okay. I guess the problem I have with what you're saying is it's not clear to me what the word invariant light velocity means. And you've modified that by putting in the words measure. Okay. So
How
that,
would you describe it?
well, I think this is the issue. The issue is Einstein would tell us that anytime I make a measurement, irrespective of the velocity of an inertial observer, I always measure the velocity c to be the same. Is that not correct?
What is that again?
My understanding of what Einstein says, or what the belief is that irrespective of the motion of the measurement apparatus, the velocity that's measured is always c.
Yeah, yeah. I mean, that's the going theory. Yeah.
So the
I don't
question,
know if I agree.
so you're saying you don't necessarily, so the issue really boils down to is what is the motion of the observer or the motion of an inertial frame mean?
What does the motion of an inertial frame mean? Well, So simply like if there's another frame that moves towards it or away, and they're traveling at a constant velocity, that's that about explains it, I would guess.
So, so the question is, if I'm at rest and I say that I'm an absolute observer, I'm on the surface of the Earth, and you're moving, and we both have identical light velocity measurement apparatus, then you do not necessarily think that the two measurements will produce the same result. Is that what you're
Well,
saying?
I guess I would personally say that once it's determined through experimentation, through measurement of light sources, if it turns out that C is always invariant, then you could just simply apply that to what you see, whether it's a light source or object traveling in its space or however. You can just apply that knowledge to that and just make that conclusion without having to measure it again. You know.
Um, all right. I think a lot of this has to do with the what the word invariant means. It seems to me that the speed of light is invariant with respect to an absolute frame.
Well, I don't think an absolute frame is necessary at all, personally. I
So
can see
now,
Vladimir disagreeing, but and that's cool. I mean,
well, but if the speed of light is the same relative to the ether frame, and it's c with respect to the ether frame, then if you were to say the speed of light is invariant, that doesn't really mean anything unless you say relative to something. You have to tell me what the measurement
relative to
is.
whichever frame of reference that you're measuring. I mean, I would personally say that okay, as far as absolute frames go, because here you've stated that the ECI frame is the one to go by. But however, if you were on Mars, I'm sure the conditions would be the same there to where you would consider Mars the absolute frame if you happen to be there, or even in a spacecraft in outer space.
So that says that the local frame is absolute.
I wouldn't say that any frame is absolute personally.
Well, if you
Well,
say that, then you can't
well,
really do a measurement. That's a problem.
Well, you can easily do measurements from any frame that you want where it's possible. And even where it's impossible, you can conclude that I'd probably get a similar result from that position in space or wherever that you're at.
All
I
right.
mean, why
But
wouldn't it work elsewhere?
let's hold on. I mean, we're not really measuring the speed of light on Jupiter yet, so that's not really an issue.
Yeah, or
Um,
Mars. Well,
so I'm not sure.
maybe we have on the moon.
Well,
I know they've done experiments in spacecrafts where they need like a source where they're at, whether it involves the velocity of light or it doesn't. I mean, they perform experiments in spacecrafts in zero gravity just to see how things would work. I mean, they're going by that frame. They aren't going by the Earth-centered inertial frame.
Do you accept a local ether frame? Jerry? Okay, fine. I wanted to establish that. I think you are. Because if you do, you've established a de facto. I mean, forget about the further question, which Jim and I were discussing a few minutes ago, about whether there really is an absolute frame, but a de facto absolute frame that you can use. Because you introduced your topic earlier on by saying the relative velocity, I think you said, between the light ray and the observer. But you see, that's accepting that there's no local ether frame. If there is a local ether frame, well, then there's no such thing as relative velocity, or at least that's imprecise. The two situations that I just talked about, namely one where the source moves relative to the observer, and the observer is stationed relative to the local ether frame, and the converse. They're quite different situations. It's not just relative velocity which matters.
Well, I would say as far as the ether goes, if there is an ether, if it is determined, like if the velocity of light is determined by, like if it travels at a fixed velocity relative to only the ether may be considered an absolute frame. However, not to the extent that that objects on Earth that move relative to each other or anywhere in the universe that you couldn't compare them and just consider them separately apart from the absolute frame. However, though, I don't know if the ether exists. If it does, it's possible that that light doesn't travel at a fixed velocity relative to the ether, as many etherists, I think, suppose.
Okay. All right. We got let's see, we got 4 minutes. Would you think that if let's say, for instance, I propose to you on the order of what Vladimir says, that there's a thing called a cosmic medium and that it exists, would you say that the speed of light is invariant with respect to the cosmic medium? Would you
Well,
accept that as a
that's sort of the question that I was sort of asking, except in regards to the ether. If the cosmic medium or the ether, if light travels relative to only that, why have we arrived at such consistent values? Whether they're fabricated, if they're fabricated, that's understandable. But why have they arrived at such consistent values, 186,282 miles per second on Earth, whenever it's been measured in the past?
Well, it's measured on Earth. That's the number that they use based on Earth measurements, based on Earth standards of measure. Like, for instance, there's a measure of time defined and a measure of distance or
Yeah.
length defined.
Well, if light only travels relative in a fixed way relative to the ether or the cosmic medium, it would seem that when we clock it on Earth, that we would arrive at different figures all the time, given the Earth's spin, the rotation around the sun, and such.
And we do. We
really?
measure speed of light westwards exceeds speed of light eastwards. Those experiments exist. I mean, it's programmed into the GPS.
Which is what's the Michelson and Gale or something else?
Well, the Michelson Gale would be one early experiment of that, but I'm talking about the Sagnac correction for the spin of the Earth as distinct from the rotation of the Earth, because that's a second order effect, very, very hard to evaluate, although it can be evaluated. So you can send a radio wave, and these experiments are done. I mean, they're done all the time by GPS. You send a signal westwards, and it has a greater speed than sending it eastwards, the same distance on the Earth.
Because of the distance it takes to travel because of the Earth's rotation.
So you're back to the same. Okay, explanation is a nice way of putting it. I say cop out that the mainstream say.
Well, how is it instead?
Yeah, that's right. It is a different distance because the Earth is spinning towards the ray in one case and it's spinning away from it in the other. But from the point of view of the Earth itself as a fixed system, if you say it's an absolute frame, well, then the speed is actually changing because the speed from New York to San Francisco is greater than the speed from San Francisco to New York.
Because of the Earth's rotation.
That's okay, but why? Why do you think because of? I mean,
well, how else is
fact of life? So like I'm claiming, and it's fair enough. You're analyzing this very deeply. I've had a quick look at some of the emails going through that Harry referred to. I haven't contributed to them recently, but I was actually surprised, to be frank, that Cornelius is taking a very, very mainstream view of this whole thing. And you're more agnostic.
He typically does.
Yeah, I didn't realize that. I thought he was a bit more,
All right, we got less than a minute here, so I understand what you're saying. Do you want to we'll come back to this and after the break here. I think this is an issue. I think people have different perceptions about what is meant by the speed of light. It's relative to what? Is that?
Well, I mean, like whatever frame you're measuring the velocity of light, if that's how you measure it, that's how it is for that particular frame of reference, I would say.
Yeah, and Ian just explained that it's different going east to west.
Well,
yeah. All right.
Okay.
Ian, you were talking and we got a little I think we're getting closer to the difference. My understanding is that when you're talking about these particular examples, we're running into the problem of relativity, and I'm not real clear about whether general relativity modifies this or not. Says that for two initial observers, the speed of light is always the same, irrespective of the relative motion of the observers in the inertial frames. But none of these experiments that we're talking about deal with inertial frames. They're always dealing with, the real situation of being on the Earth. So I'm not really sure. I don't know how, in principle, you can verify a theory that involves inertial frames that are fictitious and don't actually exist in the real world. So I'm not really sure what applicability we have of a theory that can't really be verified by any real experiment.
I would say I definitely agree that that there haven't been experiments. Well, okay, maybe there have as far as the Romer observations. However, though they haven't like definitively tested a moving source where there's like a stationary sensor that clocks the velocity of light that way. However, though, okay, I'm losing train of thought. There was like another point I was trying to make that I can't remember.
I think the point that Harry just made is a key point. I mean, is a very fundamental point.
Well, how would you describe it yourself, as far as what Harry had mentioned?
Well, in what you just said, that a moving source with a stationary recipient of a light signal, which was let's see, that would be your left hand that you use, relative to what? You see, because you could say in another frame the source is not moving, but your left hand is moving. You see the point? Your right hand was moving, but your left hand was stationary. Move to a different frame, and the situation is reversed. And so you're going around in circles or not. That's my opinion. I think you need an absolute frame. And this whole idea of vacuum, a light speed vacuum, perfect vacuum is just the absence of ions and atoms and molecules. Okay. But in my work, at least, whether you accept the methodology that I use with computer simulations and so forth aside, I think it's a question that what is the content of perfect vacuum? That there's a lot of energy there, and many physicists agree. This so-called sea of particles and sea of virtual particles and so forth. So even the idea of what is vacuum is questionable.
Well,
in other words, are we really asking the science questions, or is this more something other than science? I don't know.
Well, I would say that a vacuum is just the emptiness of space, which, according to most scientists, doesn't exist. I think, however, that this is like going off on a different tangent. That there is an emptiness, a void, which all physical phenomena fills, and that is space. I don't think that space is something apart from that. However, though, what you were saying about what was it? Damn.
The energy content of perfect vacuum.
It was right before that. I'm sorry for my incoherence.
Well, I was saying, what if you reversed which was in motion, your right hand?
Oh yeah. Well, I mean, like if either were in motion, like if they weren't stationary relative to each other, you would seem to get a different result. If C isn't invariant, if C is invariant, you would seem that you would get the standard value of C. However, though, I'm unsure of what to make of the Michelson and Gale and the Saginaw effect and the Wang experiments.
Well,
I mean,
I'm Jerry decrying the common explaining away of these effects. Um, they've taken a dogma, namely SRT or GRT, and when you show that this isn't the case, they say, well, okay, you're not an inertial frame. You've done the experiment of the Earth, so that's why it doesn't apply. Or they say because the distance is either closing in or expanding out. So and I have a sneaking suspicion that even among people who are distant-minded to some extent, it's sort of in their unconscious as a bit of a dogma, and one is trying to explain away things by talking about the distance. I mean, as I've said, you don't say to me, "Oh, I know I'm driving at 50 miles an hour, and there's a car coming towards me at 30 miles an hour, and the relative speed is 80, but it isn't really 80. That's just because I'm moving towards it." Nobody would. You'd be idiotic to say that, but that's exactly what you're saying in terms of the speed of light. And I would say, actually, if you do a simple geometrical analysis of the system, you prove two things, because you say, I think there isn't sufficient experiment. You prove that the speed of light is constant when the source moves, and you show that it's c plus or minus v when the object moves. Now, for example, if the speed of light, source-wise, took up the speed of the motion, if you have this ballistic effect, well, then there'd be no Sagnac effect, because that would exactly compensate the change in distance, as I say, the drawing in or the expanding out, depending which way you're going. That isn't the case. So the Sagnac effect is actually a very, very valuable piece of experimentation. It shows these two things, I would claim.
well, I'm not saying that I agree with mainstream as far as anything else goes, but I mean, it seems that with the Saturn effect and the microsonic gale and the Wayne experiments, that the light does have to travel, just one of the light waves has to travel a bit further than the other, which could result in the interference fringe. I mean, maybe I just don't understand it correctly.
Yeah, well, that's true. From an absolute frame point of view, that is quite true. That's true. And the same thing for the two motor cars approaching each other. If you're above that, looking at it, you see that the distance is changing. That's quite correct. But if you're actually in one of the vehicles, the relative speed is increased or decreased depending upon which way you're going. So I think you're a bit biased, maybe by. Well, look, no, I don't want to be too.
That's cool.
A good sense. I think when you're agnostic, I mean, you say, look, I'm looking at both sides and I'm open, which you are. You certainly are. You're a thinker, an open-minded thinker. That is a superior condition to be in than a dogmatic person who says, I know that this is right and you're wrong and I won't even listen to you and you should be cancelled and so on. So you've got a
Here, Ian.
Do you agree with that? Yeah. That's who's that? That's
That was Rick.
Well, yeah, it's
Katie, friend. I'm sorry, I forgot your name. Thanks very much. So, I don't see you here actually. Maybe just Rick. Thanks, Rick. It's just your face isn't there. So you've reached a superior position to the dogmatism. However, I'm arguing that maybe in this instance you could go a little further. If you just look a little more deeply at the Wallace experiments, you've looked at the Romer experiments, yeah. If you look at the Sagnac experiment, maybe look at the geometric explanation of that.
I definitely don't.
Kelly, for example.
I would say I definitely don't deny that C possibly isn't invariant. I disbelieved it for so many years. However, though, like if C isn't invariant, do velocities add? Is that the way that it works, or is it something else somehow? Because I don't know.
They add or subtract.
Add or subtract. Yes.
Yeah, depending upon whether the observer is moving towards the source or the observer is moving away from the source.
So they would add or subtract.
Yes.
Okay. I wasn't clear on that. I thought that I'd heard. I thought that I heard you say otherwise the other day or something. Maybe I was misunderstood.
Did you think I was inferring that there was some other weird type of equation?
Oh, I didn't know.
Yeah, because so that's the relativistic. The relativistic equation has 1 plus v1 v2 over c squared.
Yeah.
In the denominator. No, I don't accept that. That's a fudge. It comes out of the Lorentz transforms. If you accept them. Although I'm a bit hesitant to talk that way now. After yesterday's talk, he was talking about Voigt, and we ought not to be considering them transforms and so on. But anyway, if you take it as Lorentz transforms, you get this thing. No, they're framed. They're framed in such a way to ensure that C is always constant, independent of the motion of the source or the observer. Now, Lorentz, who effectively has the same theory as Einstein, except with an absolute frame, he said that comes out of it. Yes, I admit it comes out of it. But he said that cannot be accepted without some very deep reservation. Some words like that he used. Lorentz said that.
Now, isn't the Sagnac effect used in guidance technology today in a practical application?
I think so.
Yes. Of course, yes.
Well, in other words, there seems to be a credibility in the results of that sort of arrangement. Human lives are put at stake using this as guidance system. So I would think that would weigh very largely, bigly
Well,
in the whole.
I would definitely say that the Sagnac effect is very relevant when considering systems that rotate. However, I don't think that means that light isn't invariant. I mean, I don't know, but light takes a further distance to travel within a system that rotates, or within the Earth's rotation with the Michelson and Gale experiment, where there's like these distances apart, sensors and light sources. There's more of a distance to achieve, so it seems that the interference fringe pattern seems understandable. That's the mainstream view, and I don't always agree with the mainstream, of course, but I don't know personally if it's correct.
It's the mainstream. You're right in describing it because the distance does change. That's a correct fact. But it's the mainstream cop-out. They're trying to protect the view that light speed is invariant, independent of any motion at all, relative motion. And then when you put it to them, but look, this is the thing, and as Jim says, our daily lives, if you go into a jet airliner, there's no mechanical gyroscope there. It's relying upon the Sagnac effect to navigate the aeroplane in yaw and in pitch and in roll. And when you're sitting on the plane, you have confidence that if you didn't take this into account, the plane would crash. So that's true. But see,
I talked about that yesterday, as I recall. It's called a fiber optic gyroscope.
Yes, he did refer to that. And by the way, I think I've told you all this before. I've been in touch with Wang,
Wow.
He got in touch with me, and I asked him twice to give a talk on Saturdays, and
Wow.
he's very politely declined. He said he's happy to keep in touch with us and so on. And I don't know what it is. I think it might be the level of his English or something. I'm not sure.
If you look at the image that's being shown right now for me, roll pitch yaw. It's real quick. You took a long time to say roll pitch and yaw.
Okay, guys.
Yeah, I don't see anything. You've airplanes there, yeah.
Airplanes, roll pitch and yaw. Yeah, that's the
it's a
three
roll pitch
control.
and yaw.
Yeah.
Okay, very
Okay.
good.
You were stuck. You were stuck on pitch there for a second.
I was because you can mix. You can
Okay.
mix up. Yeah.
Okay, it
Yeah,
doesn't
yeah.
matter, guys.
Yeah, I'm just
doesn't-
having some fun.
Guys, let me give you a few comments about talks today because I was so patient. I was looking and I'm
Thank you.
telling something to myself. First of all, Jerry, even the notion of movement depends on what? Relative to what? You're talking about frame, car moving against road, And what about this? Even the objects, the light moving against what? Relative to what? It means that I absolutely agree with Jim, with Harry, with everybody that you must use absolute frame of reference. Even notion of movement depends against what? Relative to what? That's
Well,
why even the relative velocity between different frames, it depends on what, how you measure the speed of one, the speed of another one, and what does it mean relative. That's why the
well,
motion, that word motion, means against what, relative to what. This is a very
I
important.
would agree that's a good definition of motion, like that there's something
Yes, it's
to
a
move
motion.
relative to, and that objects
Again,
exist and travel relative to each other. I agree with
okay,
Einstein in this respect. I don't agree with all of Einstein, of course. However, though, objects,
okay.
what,
Okay,
what, what,
please
what, what,
stop it. We
what,
heard you.
whether there is an absolute frame, what if there are subframes that exist on Earth or just throughout the universe that objects exist and travel relative to each other? You don't need, when you look at a bicycle that travels on Earth at however fast, 30 miles an hour, you don't look at the absolute frame to determine how fast it goes. You look at the Earth, the reference frame of Earth. You know,
Okay, then please have your patience. I was patient for 40 minutes and plus.
well, I mean, it was
Please,
sort of the
couple
presentation. I mean,
minutes,
you were
wait.
pacing, yes,
Oh
but it
my
was my
goodness.
presentation, and it's cool. I
All
mean, I
right, all
don't
right, all
blame you at
right,
all.
all right.
Hey, stop him, please.
I'm not sure what the point of disagreement is.
There is no
An
disagreement.
absolute
Let me
frame.
continue, guys. Let me continue. Please stop. Have your patience for a couple minutes.
Okay.
Movement depends on absolute frame of reference. The next very important point. Believe, not believe, you're physicists. I don't want to hear even this word believe. We are not believers, we are physicists. Physicist means based on experimental results. You don't believe that absolute frame or cosmic medium, in my words, there exists. You're absolutely wrong. Why? Because microwave background radiation, do we have it? Yes, we have. Do we have fast radio bursts? Yes, we have. We measured even the concentration of intergalactic plasma. Do we have far infrared background radiation? Yes, we have. We proved it. We confirmed it. That's why the believe, not believe, it doesn't matter for me. Because you may be believer, go your way. But I'm physicist. And if there is something filling our around space or whatever, it means that it exists. This is the second very critical point. Please stop believing experimental
Well, I mean,
results.
I
Okay,
would
let
say
me
that I
continue.
would say that we all have beliefs, all of us, every human
You
being who
believe I
exists.
don't.
However, though,
I don't, not all of us.
if what you say doesn't prove that there's an absolute frame, though, I don't think personally.
Okay, you believe, continue believing because dogmatic orthodoxies, they believe in vacuum and in all this bullshit. That's why believe, continue to believe. That's why I didn't achieve my goal for many, many times. I talked about the cosmic medium, existence of it experimentally proved. Nevertheless, you still believe that there is no, and what does it mean vacuum? You don't know either. That's
Well,
why, you know,
don't you think that the cosmic medium consists of protons, electrons, and photons,
I
and
don't believe
travel
it's
in so
measured
many directions?
concentration of intergalactic plasma measured experimentally. There is dispersion of radio waves. Based on this dispersion, they calculated by classical physical laws what is the concentration of it. And my calculations exactly correspond to these experimental results. Please, let's stop about this issue. Let's continue because, you know, I want to continue my small comments.
Cool.
That's why cosmic medium does exist. Do you believe, don't believe? I don't care right now because I'm experimentalist. If there is some experiments, they proved it, forget about it. The next very important point, speed of light in vacuum. Some stupid guy, I don't know who was the first, introduced this notion to Maxwell equations. Speed of light. Maxwell didn't know about speed of light anything. He put in his equations so-named electrodynamic constant. And I don't want to talk about this constant because it's constant. There is no variation of this constant. Simple as it. Constant named electrodynamic constant. It's a ratio between some magnetic parameters and electrical parameters. And it's always the same. There is no variation of electrodynamic constant. But for you, for all these guys with speed of light, I want to tell one more time that speed of any electromagnetic wave in our space depends on the parameters of this cosmic medium, so named epsilon and mu. And this is the medium. You must take into account the medium, the parameters of medium. Then you can talk about speed not of light, speed of any electromagnetic radiation, radio wave, speed, gamma, whatever. But in cosmic medium, there are some parameters, so by the way, measured already. Take a look at my paper, and you will see there is no 1 and 1, epsilon 1 and mu 1. Mu measured with accuracy up to 7-9 points, and they found that there is a difference in this mu parameter against 1. That's why.
Well, okay. According to your view, the Earth travels through the cosmic medium, right? If it does, when we measure the velocity of light on Earth through countless experiments, when we measure the velocity of light on Earth through countless experiments, why has it always resulted in 186,282 miles per second every time? Unless they fabricated it somehow and pulled it over the eyes of the scientific community. Why? I mean, like if it results from the cosmic medium and that light travels only relative to that, why wouldn't you achieve different results each time? Because of the Earth's spin, the rotation of the Earth around the sun, you know.
But you do.
I have my patience with you. Please have patience with me too, because this is the third point. That's why electrodynamic constant, it's constant in my model, in Maxwell equations, and he compared the calculated electromagnetic speed of electromagnetic waves against the very first measurement of speed of light. I don't like the speed of light because there is speed of electromagnetic radiations, electromagnetic waves. Light, you don't know even what does it mean light.
Light is within that category.
What does it mean light in your words? What does it mean light?
Light is an electromagnetic wave, isn't it?
Electromagnetic waves, yes. This is exactly what exists in Maxwell equations. And there exists electrodynamic constant. And when he calculated, he saw that calculated by him based on electrodynamic constant velocity is close enough to speed of light, so named light, measured experimentally 10 years before. You see, they were close to each other. Maxwell never told it's the speed of light. I don't know who put this in equation. He spoiled it. He's done so great, the great value of this, speed of light inside of Maxwell, of course. So special relativity, general relativity depends on this bullshit because it took from your beliefs, from your head, from where? Because in Maxwell equation, it doesn't exist. It doesn't exist. There is no such parameter. And your measurements of speed, so named light, it's experiments in some wavelengths range based on Earth, on Jupiter, whatever, whoever. It doesn't matter for me. It's a totally different story. There is electrodynamic constant. It's constant. It's measured already. It has a fixed value right now because the cosmic medium, what we have right now, this is the last point I will not tell you. It's so rare, so low energy density that the moving this ether, not moving ether, it doesn't work. Because many times I told guys, in our cosmic medium, there are only one proton inside of 4 cubic meters. What kind of medium? What kind of resistance you are expecting? That's why all these experiments, they show that speed of light is not variant, invariant, and all this stuff depends on the behavior inside of this very rare field cosmic medium. 1 proton per cubic meter, and it's measured. It's measured. It's not your belief. How we can influence on our movement?
That's quite impressive. I've heard similar predictions. If that is so, does that mean that there's empty space in between them? There's
no empty space. One more time, please.
What's in between the particles?
Number. Real notion is cosmic medium. There is a cosmic medium with these parameters.
But
Simple as
isn't
this.
that composed of protons, electrons, photons, and such?
Yes, not all of them. Protons, electrons, photons, neutrinos, and so named universe created particles.
How to know that,
90
though? How can
92
you determine that?
What? What is your question?
How can you possibly determine that?
Determine what?
That the cosmic medium is composed of protons, electrons, photons, and such.
You know, I wasted my time so many times with you. I will tell you why. Because fast radio burst, dispersion of radio waves, it exists, it's experimentally measured, and there are calculated based on experimental results the concentration of these protons. You don't believe it? Okay. It means that I will never succeed with you because you are so rigid, so solid. I don't believe in that's it. Simple like this. Be
That's cool.
physicists, experimentalists. Forget about your beliefs. You are not in a religion right now. You're on a cosmological group right now.
Well,
Please follow
science isn't only about experiment. You have to interpret the experiments. You have to use reason and observation. You know.
your experience about vacuum, about not existence of cosmic medium. Tell me your proof, confirmation of your beliefs. Where is your belief?
I'm of the questioning spirit that I admit that I don't know. I suspend my judgment on many fronts. I have to admit.
1 second. Answer my question. What are experimental results that prove that you have vacuum or whatever you name around us, and you are moving against what? By the way, for your experience, 1 second.
Oh,
1 second.
you mean
For your point, the speed of Earth against the cosmic medium measured. Go to Wikipedia and you will see very good measurements against this one. The speed of sun measured. The speed of our galaxy measured
that doesn't mean
against
there's a cosmic
microwave
medium,
background
though.
radiation.
That doesn't mean there's a cosmic medium, though.
No, I failed against you. Forget it.
I'm sorry, Vladimir. I love you.
It's impossible. You are not physicist. You are a believer. You are in religion. Let me tell you the last point.
Right.
Guys.
Okay. Let's sort of.
No, Harry. Let me finish.
What is it what's your last point that you're trying to make?
Yeah, I tried already 5 minutes, but I keep succeed. You know, because Jerry doesn't believe me. Believe.
Yeah. Well, this is. Hold on. You've hit upon what really boils down to, I think, the fundamental issue, and I think you made this point maybe not as clear as you could have. I think Einstein comes along and he says, well, I've got this theory and I can do away with having ether, cosmic medium, ether. We can do away with that. And I got this theory that I've invented out of philosophy. His theory is just philosophy. And he sold the physics community on this theory of philosophy. It's just philosophy. It's not based on experiment.
What's wrong with philosophy if it's accurate philosophy?
Well, that's what the issue is.
Philosophy with words. It's not experimental science. Forget it. Harry, you're absolutely right. You're absolutely right.
You have to observe.
But philosophy, religion is a philosophy. Religion is philosophy. What kind of religion you have right now, Jared? Tell me.
Religion is maybe a philosophy. I wouldn't say it's quite an accurate philosophy always. However, though, like not all philosophies are accurate. Just as all scientific theories and experiments don't produce accurate results.
Okay.
Let me tell you my point. Harry, let me tell you the last point because it's a very important point, and you will see why. First of all, I told you already 3-4 points. Now the last one. The last one is all our speculations about special relativity, general relativity, all of them based on the closed system, universe as a closed system. That's why you can talk about all these equations, what we have right now, these conservation laws, only for the closed universe. But unfortunately for you, Jerry, it's not closed. It's empty. Or this opened. Why? Because all the seconds inside of our world is coming new matter. There is a variation not only in matter, in the medium, in the cosmic medium. There is a variation in these constants, epsilon and mu, parameters of this medium. That's why your measure right now, so-named speed velocity, or in hour, it will be totally different in maybe 12 signs after the comma. Why? Because the parameters of medium change during this 1 hour, 10 hours, whatever it is.
Oh, I would
That's
definitely
why
agree with
in
that.
principle, 1 second, in principle, there is no invariant of speed of light. First of all, I don't know light, I don't know speed of light against of what. And what is important, you're measuring every time totally different point of the universe with a totally different, principally different, not total, principally different parameters of this cosmic medium. Simple like
Vladimir,
this, you see?
would you say you disagree with the invariance of C then?
Invariant, no. C is an electrodynamic constant. It's constant. But speed of light, you named it, it's invariant all the time. And it depends on when you will measure it, because parameters of the cosmic medium varies. Simple like this. That's why I agree with you. Speed, yeah, you cannot be absolutely sure that you measure today and tomorrow it will be the same. No, it will be principally different. But everything depends. What is the meaning of speed of light? And don't put it into the Maxwell equation. It doesn't belong to Maxwell equations. You see what I mean?
Yeah. Well, why have physicists, I mean, like countless physicists who measure the velocity of light on Earth, why do they always arrive at the same value unless they're doing some fabrication that we don't know about?
I tell you, no,
Roger.
one second. We have our Earth. We have sun. Do you know that there is a cloud, some shell of these particles around our Earth, around sun and all this stuff? When you have electromagnetic waves going to sun or to the Earth, it's passing through this shell of plasma. Do you know that there is some plasma around our Earth? Do you know this? You believe it?
There probably is. I wasn't acutely
Okay,
aware of that.
then you must take into account, you must consider the existence of this plasma
What
around
is its
our
relevancy?
Earth. Around Earth. You must take care about it. And to tell, guys, my signal goes up and down through this shell of plasma. And nobody talking about it. Even you didn't talk about it. That's why accurate measurements must take into account all the parameters of the medium, not of intergalactic medium that is between. If we have a medium, galaxy medium, intergalaxy, we have intersolar system medium, we must take into account them. That's why to talk about invariant of speed of light based on Earth, there is no meaning of it. Because you don't have vacuum around your Earth.
So you don't
We are
agree
not moving
with the invariance
inside
of
of
C?
vacuum.
I mean, I admit that I don't know if C is invariant.
Space is filled with varying amounts of plasma, and that's a fact. And all the gases and dust that you hear cosmologists talk about, replace those words with plasma, because anything suspended out there is a charged particle. And that's the definition of plasma: ions, atoms, electrons, and what's the last one? Help me out.
Neutrons?
No,
Neutrinos?
no, it's a conglomerations of atoms,
Molecules.
molecules. All of that is plasma. All of that is considered plasma. And the universe consists 99.9% plasma. Done.
Absolutely wrong. About the plasma existence, you are right, but absolutely wrong. 92.8% exists in form of universe created matter, universe created particles. For your personal, you, 2.4% of our normal or ordinary matter inside of all our galaxies, sun and all this stuff. 2.4%. The concentration of this intergalactic plasma between galaxies, 4.8% only. All this ordinary matter, it's only 7.2%. All the rest, what? Energy, dark matter or dark energy in our standard models. You see, the whole model right now based on dark energy and dark matter. Instead of these bullshits, I introduced cosmic medium composed of these particles I told many times. That's why
Right.
you cannot build any physical model based on 2.4% of your
Right.
matter,
And how do we
including
know?
your plasma,
And how
including your plasma.
and
How
how
you
do we
can
know?
build the whole universe based on 2.4% of energy
And
or
how do
energy
we?
density of
And
matter? How?
how do we know the densities of plasma between galaxies, within solar systems, around solar systems? How do we know that? We know that due to radio
We don't know.
telescopes
We measured
and
it.
we see the magnetic fields that these moving charges create. It's not these magnetic fields between galaxies are the cosmic web. That's how we detected the cosmic web. That's we know that there's the movement of charge creates magnetic fields, and you don't need any dark matter or anything like that, or dark energy, to have a universe that's based on an electric charge moving and creating everything that we see, pinching down, creating suns, pinching down, creating galaxies, rotating everything on the right-hand rule. Uh,
Okay,
Go ahead.
okay. Thank you so much. Thank you very much. First of all,
All right, we got 4
you
minutes.
didn't answer my
No,
question.
2 minutes. 2 minutes.
Okay, we will continue. 2.4% of matter in our galaxies and all around that thing. All the rest matter is totally different story. That's why you cannot build your theory based on 2.4% of matter instead of 100% of matter.
Well, you
This
leave
is a
out the
very important point.
if
For
you don't
1 second,
if
1
you
second,
don't
we have
if you
not so
don't add
much
the
time.
electric force into the picture,
1 second.
pinching everything down, you don't need dark matter. So go ahead.
You're absolutely wrong. First of all, there is no dark matter. The very important point for your convenience. Please take a look with ChatGPT, with everything.
I didn't say there was dark matter. I said
Oh,
you
you
don't
okay?
need
There is
dark
no
matter.
okay. For you, please listen 1 sentence only. There are so named dark magnetic fields. They are not connected with electrical charge at all. Please find these
Yeah, it's
papers.
called
You
static. It's
can go
called
to
static
my
charges
paper.
when plasma rubs up against each other in dense
Plasma, you
plasma.
misunderstood me. I told you there is no plasma. There are so named dark magnetic field. There is no plasma. There is no particle. There is nothing, and there is a magnetic field. How you can explain it?
All
Movement
right,
of charge.
we're gonna cut off here in a minute. We can
People who know so small.
continue
There are so
discussion.
named dark magnetic field. Please explain me. I explained in my view. Please give your explanation how it goes. And I have a special paper considering these effects of magnetic field. And you know why? Because magnetic field here, it's answering to your question. It's movement of my magnetic dipoles. Dipoles. There are no charges responsible for magnetic field. There are dipoles. Dirac's
Field, Vladimir.
All right, Rick. Let's not. I probably should have stopped the. Probably interrupted a little bit, but I think it's interesting to hear what different beliefs people have, and I think I'm sort of inclined to let it go. And since the timer immediately is going to cut off the discussion, that sort of puts an end to it. Okay, what I'd like to do here is, I think I approved Roger's request I wasn't paying much attention. Roger, did I approve your request?
Yes, okay. I'm all right. Yeah, thank you.
All right.
And,
I guess
Roger wanted to say something in the last session. What was that, Roger?
Yeah, I just wanted to say that it might be an idea to show Sheldrake's talk, because in the email discussion before this Sunday session, they were talking about that, and it sounded like that Cornelius hadn't seen it, for example.
Sheldrake, I'm not sure I saw, I'm not sure what you're referring to.
Well, Sheldrake gave a band talk, and part of it dealt with the speed of light, and that was referred
Rupert
to
Sheldrake.
Rupert Sheldrake. Yeah, unfortunately, it's in
All
the
right. Well, all right. I want to sort of, we got 40 minutes to go. I'd like to have Jerry sort of see if he could give us a summary, and people want to make some kind of a final comment on that, and then I'd like to move on to some comments about yesterday's presentation, and like to hear what people who saw that, what their thoughts were about that. So Jerry, could you sort of wrap up your discussion?
Oh, yeah. Well, actually, I personally wouldn't mind seeing Rupert Sheldrake's band TED Talk. However, though, as far as the invariance of C goes, like essentially, I don't know if C is invariant. Yeah, like why doesn't the motion of the truck, like throwing an object off a truck and the velocity is add, why isn't that true with the velocity of light? And like Lorentz transformations of relativity were meant to account for that the invariance of C, though I don't know if they accurately account for it. As far as I mean, what if it's just a misunderstood and mysterious anomaly of the universe that we just can't scientifically explain yet?
That seems likely to me.
Oh, what now?
I kind of am I'm of the view that Einstein messed things up, and kind of interjected philosophy, and it sounded good, but it kind of doesn't really work mathematically. The Lorentz transform doesn't really work mathematically because you get these paradoxes, and they've kind of ignored the paradoxes. But then he sort of brought in general relativity, which sort of, in my view, created a contradiction on top of contradiction, because it's not clear how special relativity jives with general relativity, because it seems to me that with general relativity, Einstein brings in the idea of a cosmic medium. Although
actually, though, I think I have just a bit of insight, even though I disagree. I have a bit of insight that I didn't even know until recently. I'd always asked, like if velocity of light is invariant, or just okay, like if relative velocity causes time dilation, like and they talk about the principle of equivalence. Einstein speaks of that in general relativity, and that what essentially that means is that if an object can travel at a relative, like at a constant velocity relative to another source, that if that causes time dilation, he must have thought that if you accelerate, that would even cause more. And given that the inertial effects of gravity and acceleration are equivalent, because I always ask the question, does acceleration cause time dilation because of the principle of equivalence? People always said no, but when I was asking ChatGPT like a couple months ago, maybe it was saying that yes, like acceleration does cause time dilation, the same inertial effects as gravity. Like with the popular elevator example, when you're being pulled up at a constant velocity, it simulates the effects of gravity. Similar to as if you were just stationary on Earth, and if you were free falling in an elevator and there are no windows, and you didn't know you're free falling, you might as well. It would create the same inertial conditions as outer space. However, though, he did arrive at curved space-time and other theories that seem apart from that particular idea, which I personally disagree with. But that's just my personal revelation that I've had recently, even though I don't agree with it.
All right. Does anybody have any more comments about Jerry's?
Maybe just one more thing, Harry, and in view of what Vladimir was saying and so on. I'm coming back to the analogy. Like if you take a certain amount of air at standard temperature and pressure, and it has a certain density, and you find that actually, if there's a disturbance in that, it travels at a particular speed. Okay, it depends on the properties of the medium. So that's a fixed value for this portion of air, let's say, oxygen and nitrogen and so on. Now, that happens to determine also the speed of sound in that area. So in other words, if you have a little clangor, a little bell with a hammer on it, and it emits sound, well, that will be transmitted through compressions and rarefactions, and then you can either have a detector or you can have an ear at the other end, and you can find that that's the speed of sound. But I mean, if now you could do an experiment. If that little clangor moves towards you, the speed of sound is unaffected because it's actually a disturbance in, I won't call it the ether, but in the air. It's a longitudinal transmission in the air. Now, however, if that is stationary and I move towards it, it would be nonsense to say that the speed of sound is invariant because it's determined by particular properties, the elasticity and the density of the medium. So it might help a bit if you thought in terms of analogy. And if you did a Michelson-Morley experiment based on the acoustic principle, you'd probably find the same thing because you're in this fixed piece of air which is traveling with the Earth, and you wouldn't notice any difference relative to which way. So I could form a whole theory of relativity based on acoustics, and I'd get all these paradoxes, and I'd find that the speed is changing, and you get all the twin paradox and all that nonsense. So if I would just maybe, I'm sort of praying a bit that if you're open, you are open, and I applaud that. If you're open, but you're unsure and you don't know which way to go, you're completely on the fence, I would say that might help you. Just think in terms of the analogy of waves in an air medium and speed of sound. It's exactly the same system.
Well,
I would say the speed of sound.
like if you're traveling towards a sound source, wouldn't that cause the Doppler effect as well, though?
Yeah,
Of
that
course,
would change. That
if
would
you're
change the
traveling,
pitch. That would change
yeah,
the
if
pitch
you're
of the
traveling
sound.
towards the sound wave, the Doppler effect comes in, which means the frequency changes and the speed changes. The wavelength remains constant, and that's exactly the same for light.
Well, as far as sound goes, though, I mean, like if you measure the velocity of light at any point in its propagation, it turns out the same constant velocity, the 186,282 miles per second. However, though with sound, if you travel however fast and you measure that sound wave, sound doesn't behave the same way. The whole thing.
Well, it does. I mean, I don't know how you're saying that. You're unsure, but then you say light is always measured to be the same speed, and it's
I'm saying if it
the
is.
same speed. Yeah, if you see, I mean, if you do a little test over a very short period of time in a laboratory, obviously the spin of the Earth will not be taken up. But if you do a longer an analysis, through a radio transmission over thousands of miles, yes, you'll get it. And if you're looking at a GPS system which is triangulating, you'll get the spin of the Earth coming in. Now, you would also, with air, were it not carried totally with the Earth. In this case, the spin, it wouldn't be slipping unless it were sort of like in an open situation. We do get some open situations in the upper atmosphere, we get the trade winds, and we get various types of jet streams and so on, and they are affected not totally by the spin of the Earth, but the spin of the Earth influences those.
Mhm.
So I think it might help you if you thought
I
in
think
those
what
terms.
you're advocating is the idea of a medium.
I am, Harry. That's exactly it. Yeah.
Okay.
Here's the last comment.
Einstein sort of takes the position, as I understand it, that there is no medium, and you get to this idea of let's talk about thought experiments, and in his thought experiment, space is an empty void, nothing, so there's no medium, and then there's no medium, there's no nothing, there's no physics to talk about, but he does it anyway. And so then we have this theory of relativity, which is, in my opinion, a theory about nothing, because it's a theory about empty space.
I think he suggested that if the ether exists, it's superfluous, or that it can't be detected. He didn't say it didn't exist, just that his theory worked.
People interpret him as saying that. Go ahead, Vladimir.
I want to tell you guys, there is no vacuum in general relativity too. Let me remind you that a few years after that, Friedman equations were calculated based on so-named perfect fluid. For Jerry, for you, man, there is no vacuum at all.
I didn't say there was.
Based on a cosmic medium, perfect liquid they named it. And you to Einstein, to Friedman, to whoever. How come?
Well, I blame this on Galileo and his followers. That's another problem where they got, Aristotle, as I understand it, claimed that you couldn't have a void. Okay, so this goes back to the Greeks. Aristotle didn't believe in the void, and then you had what are called the materialists, Democritus and Leucippus, and they said, well, what exists are particles moving in the empty nothing void. And so science adopted the empty nothing void approach. And so we're struggling with this now because we want to know, what is the universe? And the teaching, as I understand it, and I guess we've got its dark energy, whatever the heck that is. So the universe is mostly dark energy, which we don't know what that is. And then the second component is dark matter, and we don't know what that is. And real matter is a very small portion of it. I guess basically the bottom line is we can't really answer this question about light and how light moves until we have a pretty decent theory about what we think the universe is, because science is going from the Earth and expanding outward, and then now we're at the point now where we need to know what we think the universe is. I think that's what Vladimir is trying to say. We need a cosmic medium or some kind of a concept that's not an empty void concept.
So what if dark matter is the ether?
Oh, what now?
I don't really
I
don't like Jim. I'm going to say this. I don't like the word ether. I prefer
it's the medium. I don't care what word you use, but
well, please don't use the word ether.
if it,
what's wrong with ether? I mean, I'm open to accepting the ether, except I haven't been convinced yet.
If there is an ether, it's got to have matter, right? It's got to be made of something, right?
Let me say what's wrong with the word ether. It has too many connotations that people want to put into it and causes confusion. So ether, what is it? Tell me what it is, Jim.
It's the medium that propagates electromagnetic waves.
Okay, and so why would that be?
It's invisible because it's the propagator. It's not. It's invisible because.
Hold on.
Well,
Why would dark
let me just make one more point. It's invisible because it's the propagator. It doesn't emit anything.
So, but what is it?
Well, I would say it's trons, but I'm not going to argue about the composition of it at this point.
So you're saying it's a physical object?
it's got, if it's a medium, it's got to be made of matter. You're right. Some kind
Okay,
of very
that's an
very
assumption.
finely, very
composition.
fine particles.
So if it's
Which one?
if it's a medium, it has to be matter. There you
Yes,
go. Now you got now
the
you're
variable
now you make
density
an assumption
that's
that you
proportional,
didn't
variable
prove.
density that's proportional to the gravitational potential, and the speed of light through it
You're just
depends on its
making a
density.
bunch of assertions based on your own belief system.
Okay, well, so is everybody here.
Yeah, that's what I was thinking.
That's exactly correct. But do you
But
realize that you're making,
I'm asking to consider that postulate.
What
well,
non-matter in the universe do we know of that acts like a wave and acts like a particle? Individual photons, which we know exist, and they have to be waving in a photonic soup. I think the medium, Harry doesn't like ether. I think the medium is photonic in nature.
Well,
you
so
have a
photons
completely
propagate
frame of reference.
photons.
you have a
An
Low-
completely
absolute
different
frame of
idea
reference.
than
Low
Jeff.
energy photons that have lost their energy, piling up and taking up space.
So they don't travel at the velocity of light as most photons travel.
No, they've lost their energy and they've become motionless.
Well, I've read that light particles don't exist. That a photon is a unit of a light wave. At least that's what ChatGPT has. It said I've always
Tell-
been skeptical
tell-
of light particles.
Tell that
Personally.
to the guys. Tell that to the guys in the university that slammed two photons together to create an electron.
How can they know what they had were photons, though, if they didn't travel at the velocity of light? How can two stationary photons exist?
I'm pretty sure the physicists understand what they're doing.
Well, I mean,
Nice.
you hear all.
Guys, let's have our patience and let's follow the Harris proposal. Let's talk about the yesterday meeting. I'm very curious. What is your opinion about the yesterday session? Please, let's concentrate on the idea of Harry. It was exactly my point to propose the third part of our session today. Go with the discussion of the yesterday's meeting.
Okay, so in summary, everybody's got we have a lot of different ideas about what this cosmic medium is, and so we'll just sort of so since you want to talk about this, Vladimir, do you have some ideas? Do you have some comments to make about what yesterday was presented?
You know, even for me, I know a lot about Maxwell equations, a lot. Believe me, all my life. I'm optical guy. That's why, you know, it was very difficult for me to understand his main ideas, even main ideas. The main idea, what I understood, we don't need to do any transformations with Maxwell equations. I absolutely agree with him. This point was very clear. You must do all your calculations based on the original Maxwell equation. Because you know why? It seems to me, if I understood him correctly, when we have this Lorentz transformation, we put some other transformation, we put something extra to Maxwell equation, and then we put some notions, some transformation parameters like they exist. They don't exist in Maxwell equations. Maxwell equations, electromagnetic waves, and that's it. There is no Lorentz transformation inside of Maxwell equation. That's why I absolutely agree with him. Don't go further with mathematics, because what he talked yesterday about, Maxwell equations and mathematics around this Maxwell equation. And what is the real physics and what we invented, like Lorentz equation, the transformation and all this stuff. You don't need it. It's a convenience how to calculate this equation. But when we have our computers, start from the original Maxwell equation and don't go to any other mathematical tricks. Because general relativity, it's a mathematical trick. You know, this Lorentz transformation, it's a mathematical trick. You see what I mean? That's why
Okay.
we must stop special relativity, general relativity, based on Maxwell equations. The very important point. Maxwell equations, usually we are looking for Maxwell equations in vacuum only. There is no cosmic medium, there is no ether, there is nothing. It's absolutely wrong. We must introduce into Maxwell equation some parameters of all the surrounding particles, what we have, plasma, intergalactic plasma, inter solar system, and all this stuff. It doesn't matter. Put some parameters. And then we must do some calculations based on Maxwell equations for the medium, perfect liquid, ether, whatever. But these notions, they don't exist. You know why? Because we don't know composition of ether. We don't know composition of this perfect fluid. I don't know how we can take some medium and without discussing any parameters, any composition of it, to name it as a perfect fluid or something else. The very important point, Jim, for you, questions. Your perfect fluid or your cosmic medium, like sound, it can transfer only longitudinal waves. And Maxwell equations, it transfers electromagnetic waves. You must go with theory of McCulloch to go to the Maxwell equations. You see, and even Colin already calculated these equations for this medium, cosmic medium, and he found the same Maxwell equation. It's not Maxwell equation, it's McCulloch. But nobody knew about McCulloch, how he was at least 20, 30 years before Maxwell. And this only this cosmic medium can transverse in our transmit our transverse waves. Only McCulloch cosmic medium. That's why forget about all this ether, perfect fluid, because it's a longitudinal waves only. They cannot transfer longitudinal transverse waves. You see,
Okay.
that's why all our speculations about vacuum, about perfect fluid, about ether, there is no meaning for them because they don't explain even transverse behavior of electromagnetic waves. McCulloch, this is the only one way to go. And what I've done, I took his idea about the cosmic medium and saturated it with the real particles, I suppose. And I found the conformation of all these particles in our physical experiments.
Okay.
Sorry for my emotions as usually, but what is important, guys, we don't know history of our physics, classical physics. Einstein, special relativity, general relativity spoiled it. It's now totally wrong, based on, especially on GWST experiments. It doesn't work at all. That's why we must invent something different. And what is important? It must be notions based on experimental results and logic following from these notions. That's why moving against what, relative to what, and so on and so on. If you have some medium, please, what is the composition of it? It should be some real physical notions, real physical particles. Only then you can tell something about it. Because yesterday, even the guys, by the way, Jim, yesterday, he put this question, moving relative to what? Jim, you were absolutely right. I was at this session and he did answer this question. You know, he's a mathematician only. He is continuing to work with Maxwell equations in vacuum, without any medium, without any plasma. And, you know, it's far away from the real life. It's a new approach. It's not new approach. It's a very old approach before this Lorentz transformation. Maxwell equation. But please put in Maxwell equations parameters of the medium. You have your transmitter, like you told Jim. Transmitter.
All right.
Okay.
Let me stop you here. Okay. So I think
I
you
stopped
brought up.
myself.
Hold on. So you brought up a point here. So this is the point I think I want to bring in. Looks to me like he assumed absolute space and time in his theory. His theory assumed absolute space and time.
Well, yeah. I mean, my conception of it, and I actually did spend a little time, a couple of weeks before the presentation, looking at what he put up. And I was actually impressed with a similarity between some of my ideas, yes, with regard to absolute time, and even with regard to ether and so on. And I think, he seems to be a very diplomatic type person, actually. And he's maybe trying to bring along, I think I said this actually, trying to bring along people, with him without coming in like, a bull in a china shop and getting people against. Now, I felt the lecture was very, very interesting, and he's done a lot of very theoretical work, and he's used the finite difference analysis and all that, and he's come to very similar ideas to many of mine and others. But I'm surprised he didn't seem to answer, I thought, the questions very, very well. Well, in my case, I asked him about the Navier-Stokes type fluidic analysis and the total derivatives and all that, because I thought that's another way of looking at it. You'd get the same results as what he was talking about, and he just said, "Oh, I don't bring the velocity in," or something like that. So I was a bit surprised about that.
I don't think he understood what you were talking about. I think the real issue is that I worked with this finite element analysis of solving Maxwell's equations many years ago. And when he started his talk off and he started talking about this finite time, I can't remember what the acronym was. It completely confused me because I had no idea what he was talking about. And that is a kind of a root of a problem, because if you don't really know what that algorithm is that he's talking about, if you don't really know what he means, it's kind of confusing. And I think that led to Jim's question. Jim said, what is the units of measure that you're using, or as I recall? And it
the level of resolution.
Right. And it confused him because that's not an issue in the method. The method just makes an assumption that you can break up time into increments, and you can break up space into increments.
And it was very crude,
and that's basically all it does.
He was talking about a tenth of a second. Well, actually, he didn't even know at first what the resolution of his work was, but it's very, very, very crude resolution.
Well,
It doesn't matter.
You didn't.
He's a mathematician.
Hold on. I knew as soon as you asked the question, Jim, that was going to be a problem for him, because I'm familiar with how this method works. And the way the method works is, what you do is you break the problem up into pieces that work, because if you get too many pieces, the computation gets too difficult and too complicated. And so you try to come up with an empirical way of dividing up these meshes, as he called them, into reasonable sizes that don't lead to computational complexity, but then give you sufficiently accurate results. And he was trying to explain that, but he didn't really understand your question, and you didn't really understand his answer. Is that helpful to you?
Well, yeah, I mean, it's sort of a way to keep the idea or the hypothesis that space and time are continuous phenomena and not quantized, and yet to actually do any research, you're going to quantize them.
He actually did quantize space and time. The theory, the model quantizes the space and time. It breaks them up into discrete elements. Okay, that's why it's called the finite element computational method.
But that could be conceived of as a mathematical, a mathematical instrument to solve other.
Exactly. It's maintaining the theory that space and time are continuous and not quantized. And it's basically a numerical calculation method.
Quite
the same thing is done with the proton. It's modeled. It's called quantum chromodynamics. And they create a lattice, a three-dimensional lattice, to do their computations of the so-called interactions between quarks and gluons. And so it's merely, a way to keep the old view and do some calculations.
But I think he avoided using terms. I mean, I don't. How can I speak for him? But I think he would accept an ether, and he would accept similar ideas to many of us on the basis of that. But he was shying away from being quite as blunt as saying that, because I think he wants to bring mainstream around with him. Now he is no, he's not a mainstream. He isn't. He's a professor in an established university in Gatineau, just north of Quebec. And I suppose he could be sacked if he came out very directly. What happened to Bill, whatever his name is. Just forgotten his name for a second. But anyway, Lucas.
Actually,
but on the other hand, he's not afraid. He's expressing his views, but he's expressing them in a diplomatic way. So you have to drill a bit deeper into what he's saying.
Yeah,
well,
actually,
I thought he was attempting to show that you don't need special relativity and gamma factor and so forth.
Correct.
And so on
Yes.
to explain a whole variety of phenomena.
That
yeah,
is
but he
correct.
seems confused because I've seen some of his writings in ResearchGate chats that he accepts SR.
Really?
Oh,
Yeah,
well,
I
that's a
didn't notice
surprise.
that. Yeah.
He seems confused that way to me a little bit.
Yeah, I just felt the opposite, Jim. I felt he didn't.
Yeah, well,
but that he
other
wasn't coming
writings,
out
I
straight.
agree. Other writings, I agree.
Yeah, okay.
Okay, let me give you one comment. Guys, electromagnetic waves, Maxwell equations, it's a classical physics. The notion field, electromagnetic field, it's a classical notion. That's why you can use classical physics with continuous mathematics, but the range of it much larger. Many times I told there is a minimum size, basic size, 10 to the minus 14 meters, but it is for classical physics only. I agree with James many times. Jim, I told you, your idea very good for quantum physics. When you can introduce your discrete time, discrete space, whatever. But it works for quantum physics only. Classical physics, it's ensemble of quantum objects. Maxwell equations valid for the field, electromagnetic field. Notion of field, it's a classical notion, belongs to ensembles of particles, like air around us. It's a classical notion. Air, medium, cosmic medium, that's it. That's why for quantum physics it works, but he applied your approach, his approach to quantum objects, and he transferred them to the classical field electromagnetic waves. It doesn't work this way. Where is the logic? Many times I told you guys.
I think the goal might be not to find out, to study physics and forget about these words like classical physics, quantum physics, and so forth. By the way, I reject quantum physics, as I've said many times. At any rate, I think we ought to focus, like these editorials about this is classical and this is quantum, I think get nowhere. As a matter of fact, I don't even know why these statements are being made.
Okay,
Let me ask you the question.
Hold on. I think we have a difference of opinion here, and we don't have much time left to go into that. I think we have people with different views and different approaches, and that's been expressed fairly adequately here. So do we have any more reflections on? I kind of thought what was interesting with his presentation, he seemed to me have a explanation of the Michelson-Morley experiment Was that satisfactory to you, Jim?
Not me.
You didn't agree with his explanation of it?
No.
What were your
I
disagreements?
was surprised that he glossed over the Sagnac effect too.
Well, what are your differences with the Michelson and
I,
Morley experiment?
I don't remember exactly, to tell you the truth. It just struck me
Well,
at the time.
you know the way the interferometer works, where there's a light source and there's a sensor, and that they're within the same frame. So why wouldn't light be constant if there's two stationary elements?
I'm sorry, I'm not following you.
Well, okay.
He means stationary with respect to each other.
I, I, I think you're focused on proving the ether and detecting a fringe pattern that way. However, what I'm focused on is simply that the Michelson and Morley experiment, many claim that it suggests that it proves the invariance of C, which I don't think it does that. That was my main point.
Well,
But he did somewhere say, now he may have used the word medium, I don't know, but he said, oh, this the Earth would carry this medium, and but in its spin, it would move through it. He did say that somewhere, Jim, I think.
yeah, I didn't get that his analysis of
Well,
how he analyzed it
well,
made sense to me in terms of
you're looking
rotating
for.
the instrument and
I
looking
guess you're
for a
looking for
difference.
an interference fringe that would prove that the ether does indeed exist. However, even if you can't know how fast it travels through the ether, or maybe you think that it could. However, though, what I was focused on was that it doesn't prove the invariance of C. That was my main point, because the light source and the sensor are within the same frame of reference. So if one were in motion relative to the other, then you could prove whether the invariance of C is the truth. That was my main point with that.
I think he was trying to say that the Michelson-Morley experiment couldn't detect any motion because of how it was designed. Wasn't he saying that?
Who, me?
I think
Yeah,
so,
no,
yes.
the lecturer, but he also brought
Oh, okay,
another
I'm sorry.
new thing in, which might be relevant to something you said about an hour ago, Jerry. He said something about that it's faulty because there's a phase shift dependent upon the angle of the mirror relative to the ray coming in and being reflected off it. Do you recall that?
Yeah, I remember that. I didn't buy that.
No, I thought that would be so small that he was saying it might be of the order of the what you're looking for. I think he was saying that, and I didn't buy that either. But I noticed that anyway.
Right.
Let's come back to the Harris proposal to talk about yesterday meeting. Let me tell you, Jim, I am referring to you right now. You told that there is no border between classical physics and quantum physics. And what about this double slit experiment? Nobody can explain you. Can you explain this?
Yes, I can. I'd be glad to give a
How?
presentation
All right.
on that.
Okay, we got a minute. We can't really have a big long discussion here.
I'd be glad to answer that question. Sure.
All right, why don't
Write
we?
down your answer to our session, and that's it. Please send your. I wanna. Richard Feynman couldn't understand it, couldn't explain it. If you are higher than him, I'm very happy for you.
Well, I guess I am. I guess
Well,
I
Well,
am.
but by the way, just
Please
in
write
a
down.
second or so, the complete doubting Thomas. I mean, all these magic effects, like if you put a detector in, it changes, and if the detector knows that it's actually switched on and so on. These aren't experiments. These are just statements. I want to see experiments like that have been done. I personally don't believe in them. So I
Oh,
just I guess that's a
Exactly.
strong view.
Exactly.
All right, we got. I want to thank everybody for participating today. Thank you.